So we just learned how to do a new process called completing the square, and so far it seems like kind of a nice trick, but there's not really a whole lot of practical use for it. In this video, we're going to talk about how you can use completing the square to actually solve equations. So I have a series of steps written down here that you can go ahead and copy down. I'll just kind of talk you through them though in the problems. I won't bother mentioning the steps just yet. So let's say we have this equation down here. We had to solve for x in our problem. Now, so far we have a couple methods we've learned to solve quadratics. Two I can think of right off the top of my head that you probably are most comfortable with are first the square root method. And square root method is no good here because we have that regular x in the problem, so that messes things up for us. And the other option is factoring and using the zero product property. But I'll just tell you right now, this isn't going to factor nicely, so there are no magic numbers. So that's kind of out for us too. Before this method, we really don't have a good option for solving this problem. So what I'm going to do now is use that completing the square trick I showed you guys in the last video. The first thing I'm going to do is I'm going to get this number, the c, out of here. I'm going to move it over to the other side of the equation. That kind of goes against what we usually do, because usually we want to set it equal to 0. Completing the square is a little different in that sense. So I'm going to write down my x squared plus 6x, and I'm going to put my 20 over here. Notice though that I left myself some space right here. What I'm going to do now is I'm going to put plus, and I'm going to put like a giant box here on both sides, similar to what we were doing in the last video where we filled in a number. So I'm going to do the whole completing the square thing that we talked about in the last video. So I need to take half of b, which is 3, and I'm going to square that and put a 9 right here. And if I add 9 to this side of my equation just randomly, I'm going to do a plus 9 here, I have to add it to this side as well, which is why I have a box on both sides. So when you fill in your box right here, you figure out what number completes the square on this side, and you have to add the same thing over there as well. So you do the same thing to both sides. Now, this guy on the left here, I know factors nicely, because I just made a perfect square trinomial. It's going to factor nicely. And when I do my magic numbers, if you wanted to, or just use a shortcut, it's going to be x plus 3 squared. So I end up with quantity x plus 3 squared equals, and then 20 plus 9 gets me a 29 over here. Now this may not seem any better, but this is actually a problem that we've already learned how to do. This is a square root method problem where all you do is you take the square root of both sides, you get just x plus 3 equals plus or minus square root of 29, which doesn't simplify. And you do a little factory, like I said, doesn't simplify, you just do a minus 3, you get x equals negative 3 plus or minus square root 29. So when we did that completing the square process that we just practiced, what it ended up doing for me is giving me a parenthesis squared. So I had to do completing the square to set myself up to use the square root method. Let's practice that on 2 more examples here. So we have another problem here. And for this one, again, it's the same sort of idea. You need to get this number out of here so you can complete the square. Get rid of my c. So I move that over to the other side. I get x squared minus 10x, leaving myself some space, equals, and on the side I get a negative 7. I'm going to go ahead and add in that box on both sides. And I'm going to figure out what number has to go in that box to complete the square here. So I have negative 10. Half of negative 10 is negative 5. And negative 5 squared looks like I need to add a 25 to both sides. So if I do that, over on this side, this guy with my 3 pieces is going to factor to x minus 5 squared. And over here I got negative 7 and 25, which will get me an 18. Again, once you get to this point, this is old stuff. This is just square root method problem. So we're going to take the square root of both sides. We get x minus 5 equals plus or minus. And you do a factory, you simplify your square root here. The square root of 18 is going to be 3 root 2, if you actually go through and do the math on that. And then we do a plus 5 on both sides. My answer for x is x equals 5 plus or minus 3 root 2. Final example of the video, we're going to go ahead and take away 10 on both sides here. We get x squared plus 2x, it'll be plus box, equals negative 10 plus box. And if I do my little trick here with completing the square, this ends up being 1 when I take half of it. 1 squared is still just 1. And I have to add 1 on this side as well. So this side factors into x plus 1 squared. And over here, I have a negative 9. So I go and I take the square root of both sides, and I'm taking the square root of a negative here, which would have been a problem before last week, but now we know that the square root of a negative is just going to give us an imaginary answer. So I end up with x plus 1 equals plus or minus, and that will just end up being a 3i, using our simplifying tricks with imaginary numbers that we learned in a previous video. So my final answer on this problem is going to be x equals negative 1 plus or minus 3i. The nice thing about the completing the square is that it will solve problems with imaginary solutions, and so far there haven't been a lot of methods we've had that have done that.